So here are the equations of the lines that I assigned, part of the assignment that we started Wednesday and finished yesterday. So please take a look at these. The first one, they're both in slope-intercept form, but then they're just in point-slope form for the second part. But just to go over this, again, we were using that limit definition to help us find the slope of the tangent line, but we still had to figure out this ordered pair. So not only are we given x is equal to 1, but we have the y value that's missing. So we have to determine f of 1 in this case, which will be -3. So as soon as we have the slopes of the tangent lines, we also need this point, and that's what's going to help us here. So just take a look at this and recall that slopes of perpendicular lines are opposite reciprocals of each other. So look these over. Please let me know as soon as possible if you have any questions over these two parts of the problem. And then hopefully you also graphed. Let's just show you what this looks like. So right here in blue, that's our function f of x equals x squared minus 4x. The tangent line right here, so this is the point 1, -3. So looking at this right here, that's where our line is tangent. So that's y equals -2x minus 1. And then the normal line, just by definition here, is perpendicular to our tangent line at that point 1, -3. So that's what we have here. Now, these may not look quite perpendicular, and it's just because of the window that we're looking at. So it's going off to 10 to the right and the left, but only up 6 2/3, down and 6 2/3 as well. All right, so on the next following pages, I'm going to post this as a PDF as well for you guys to work at your own pace, but I'll scroll through this. So you could pause the video here, try each problem, and then I have the answers posted on the next page. So I'll just go through this. Again, pause it to copy the problem down and work it out. Make sure you pause that, because I'm going to go ahead and show the answers on the next page. So again, if you're still working on this, pause the video. So here are the solutions. So this is just showing you if we ever see an expression like number 1, even though the top doesn't look like what we're used to seeing as a difference of squares, we could still factor it as such because of the nature of that denominator. All right, here's our third question. So this is just a graph of our function g of x. Go ahead and answer these 4 questions regarding this. Again, pause the video because I'm going to go to the next page to show the answer. All right, so here, does g of -4 exist? Yes, it is right here, -4, 1. We have a point. Is the limit of g of x as x approaches -4? What is that actually? So if we look at the left-hand limit and the right-hand limit, they're both going to a 3. So yes, that does exist, and it is equal to 3. Does the limit of g of x as x approaches -4 equal g of -4? No, we get a 3 for one and a 1 for the other. What can we conclude here? That's one of the definitions for continuity. So if that requirement isn't met, we say g of x is therefore discontinuous at x equals -4. Again, pause the video to copy this down. I'm going to go ahead and show the answer on the next page. So there's a couple ways to do this. Right now, before we extend the function, f of -5 does not exist. If we simplify this, we actually get the rational function here, 1 over x minus 5. Now, because it simplifies to this, we would still expect a vertical asymptote at a +5 based off of what we're looking at down here. But our focus is at x equals -5. So when this simplifies, if you go to look at the graph, it is going to look continuous, but it's going to still be undefined at x equals -5. So again, there's 2 proper ways to extend this function. Again, we can write the original function given here, that's going to exist as long as x doesn't equal -5. And then we could say 1 over x minus 5 when x is equal to -5, or the -1/10 when we actually substitute in a -5. So we're not concerned at all at x equals +5, just at -5. All right, so the assignment today, when you go to read some of these problems, it's going to say find the slope of the curve. That just means the slope of the tangent line. So if you still need to go back and correct the two equations we had to write out from yesterday, please do that. Continue on with logs days 11 and 12. That'll wrap up our 12 days of logs. On pages 87 and 88, 1 through 13 odd. On page 91, also 1 through 13 odd. The test again will be next Tuesday, so I will be sending you guys a link for Zoom to join as well as you take when you go to take the test. All right, so page 91 is actually going to be the chapter review. So we're starting to review a lot of these questions because now we're wrapping up chapter 2. So as always, guys, take care. Let me know if you have any questions.